I'm Patrick. I don't know if you're seeing these slides. Oh, okay, no, it's fine. So let's start. I do a small introduction about Rust, or the Rust language, the evolution of how it gets adopted by the community. After that, adoption by companies in the years. Also talk about language features, usage, and examples as well. So, what's Rust? It's a system programming language. As a system programming language, it's a language that is created to build tools and solutions. So when you talk about operating system is created in a system programming language, or is a really basic language that is designed for the development of tools and solutions that people will use to create their own applications. It's open source. Anyone can collaborate with it. Anyone can open the issue, can change the source code and submit. And the community is pretty much open. Any change of the language can happen at any time if the community approves it and it makes sense. It was created in 2006 by Graydon Hart. So it's a pretty new language compared with like C, C++, and Python. So like Python is 31 years old, C and C++ is kind of more than 40 years old. So we are talking about a language that is kind of like 6, 7 years old since the, it's around 16, 17 years old since the first creation. It's backed by Mozilla research in the creation of the server engine. The server engine is an engine that Firefox runs. And its first release was done in 2015. So it's like pretty new language, 80 years old compared to everything else that most of the companies use. And in the last year, had a 50% growth. And it was like huge. Rust is a language that is being used and adopted by a huge number of companies and also people that just do like software development. This is from the GitHub Octoverse of last year. The language is, by 7 years in a row, the most loved language by developers. What that means is that every developer that starts using the language, 86% of this person, like everybody that uses, loves it. So that's why people that start using it, continue using it, compared with other languages. And in evolution, is it also the most wanted language by all developers. What that means is that Python, that's kind of like one of the most common and most easy to start writing code, is not in the first place, it's in the second place. And this is the first time that happens. Rust is a language that is designed in a way that developers approve, and it's also easy to use. By adoption, is it also the second language to be used on the Linux kernel after 30 years. As an example, from the Android team, we feel that Rust is now ready to join C as a practical language for implementing the kernel. It can help us reduce the number of potential bug security vulnerabilities in privileged code while playing nicely with the core kernel and preserving its performance and characteristics. So it's really hard to find something that compares with C or C++ can play that well. After 30 years, the Linux kernel got a second language, and to make that happen, based on the developers of the kernel, it's really hard because they try to make the kernel as safe as possible and not put things that are not necessary. So the Rust in the Linux kernel and the number of the patches that the community created to add support for it was a huge deal. Right now, it's available on kernel 6.1, and it'll be like much more available in the further versions. Also by the Android team, Rust provides memory safety guarantees by using a combination of compile time checks to enforce object lifetime ownership and runtime checks to ensure that memory access are valid. This safety is achieved while providing equivalent performance into C and C++. So it's not something that we lose performance. You can go against C and C++ with Rust. You can have more performance than C and C++ based on the language architecture. How is that possible? I will explain it a bit further. There is also the concept of negative performance. Negative performance is where you gain performance by doing things on compilation time. So you are not doing things while the code is executing, but doing things while the code is compiling. So it's kind of a negative performance. It's like gain performance doing things on compile time. There is also updates on the NSA with like safety code that points also Rust as one of the languages to be used when creating solutions that it is safer. Also, an update from the Android team. Correctness of code in the Android platform is a top priority for the security, stability, and quality of each Android release. Memory safety bugs in C and C++ continue to be the most difficult to address source of incorrectness. Memory safety bugs continue to be a top contribution of stability issues and constantly represent 70% of Android's high security vulnerabilities. And that's not only true on Android, it also is true for Windows and other softwares that are based on C and C++, because mostly of these problems are based on human error factor. Such languages don't have a software architecture or solutions that make it easier for developers to avoid such issues. Of course, the new modern C++ standards have solutions that can be used by developers, but they are not standard solutions. Solutions that developers need to adopt and use on the code. Make the code like more verbose and more complex. Creating safe and critical applications when writing C or C++, or more than C++, really complex for people. So we should avoid adding this complexity on people and let the language and the compiler take the decisions about how safe is your code. Also, this is from the CTO of Microsoft Azure, Mark Husinovic. Speaking of languages, it's time to have starting any new projects in C and C++ and use Rust for these scenarios, where a non-garbage collector language is required. For the sake of security and reliability, the industry should redeclare this language deprecated. Yep, I totally agree. I stopped programming in C, C++ for 5 years. Most of the solutions are created from Rust. And Rust as a language can provide everything that C and C++ provides easily, with faster development time, easier development, and like more. It's really complex. If you're not coding Rust, you're not adopting it, please do. Once you start to use it, you're going to understand, and you see how problems that we face as a common thing of our day-to-day life as developers are fixed by the language using the soft architecture that the language was designed to use. And this one is from 2 weeks ago, from the conference in Windows 11, the Journey to Security by Default, from the Vice President of Operating System Security and Enterprise at Microsoft. I'm going to announce Rust in the kernel here. Rewriting Windows in Rust isn't going to happen anytime soon. We are talking about one of the most complex engineering projects in the planet. The first experiment was with dwrite. Performance increased 5% to 15%, so not only do we get memory safety, we got a boost in performance. So Rust, besides having all this safeness on by default, making lives of the developers easier, it also increases the performance of the code based on the software architecture that was designed. This can be accomplished by having things done on compile time, necessary checks and validations on compile time as well. And since Rust is a language designed to be friendly to the compiler can take decisions that will improve the code performance based on the logic solutions that the compiler can take. So some key features of the language. Ownership in borrowing, what that means. The idea is that a variable or a complex object can be or have an owner or can be borrowed. So that controls the lifetime of the object, avoiding problems with like incorrect memory access. And as said previously, 70% of the security problems on Android are based on memory access or wrong memory access. And since system programming language is a language designed to be used to create everything else, so if you develop a kernel or operating system based on C and C++, you have like 70% of these problems will be memory. So most of the problems that you use, that you're going to face, will be a memory problem. And that's what's the main point of Rust, to avoid these kind of issues because of this architecture of ownership and borrowing. Of course, that like trivial variables that are like primitive variables can be like use just memory copy, and that will be faster than a full copy of the object can be done with a single clone or a single copy. But for complex objects, ownership and borrowing take care of everything. It also has a single mutable. You can also have a single multiple reference or multiple immutable reference. That's making it thread safe. Yes, Rust is also a language designed for thread safeness. With that, developers can create code with threads in a safe way without the need to worry about how the variables will be accessed and if you're going to have problems while accessing variables that be changing by other threads. To enforce that, Rust have like atomic reference counters, mutex, lockers, and other systems that can check in compile time if your code is safe to run in a thread environment. So if you have a thread environment with Rust, the biggest problem that you can have is a double lock. If you have something like a double singleton, where a singleton depends on the other singleton, and you happens to have a double lock mechanism. But that can be easily avoided if you use like better software abstraction. There's also no undefined or null state. There's only option. What's the option? Option is something that has content or not. Or when you have a function that can fail, it can fail with like none or some. Both are options available in the enumeration system on Rust, or the enum system. It's really complex to talk about the enum system here with the time given. But enums on Rust are one of the most advanced things on the language, and brings that like to C++ in other languages. There are proposals on Python to support the enum system that Rust provides, because it empowers developers to create like much better software abstractions. That's kind of used for mostly better error handling. We also have a strong type checking. So with that, you need explicit conversion. When doing like when you want to assign unsigned value to a signed value, you can't do that in Rust. You need to explicitly say to the compiler, you please take care of this variable and convert to a specific type. That makes every single occurrence of type change to be explicit, so in the code you know what is going to happen. Different in the case where you have a signed value that goes to an unsigned variable, and you happen to have like some huge side effects that can result in terrible problems later. There is also, as I said, a powerful new system that is other languages are adopting and using as a Python as an example, as an option, result, and many others. It's easy cross-compilation support. If you work like cross-compilation to C++ on other platforms, Rust, it's mind-changing experience. The only thing that you need to do is to call the toolchain to build like cargo to use a specific target. And this specific target, you can say, I want to compile to ARM, to Apple Silicon, x86, ARM v7, ARM v8. Everything is possible. The only problem is the GNU libraries, as any other compiled language. But Rust also has support to the Muzz library, that it has a binary compatibility with GNU, but can also allow static binaries to be generated, and if that you can deploy binaries without worrying about the GNU version that the operating system is running. As an example, Apple Silicon, Raspberry Pi, WebAssembly, anything is possible. It's also human-friendly. If you are coding with Rust, the error messages, the command lines, how the ecosystem was designed to be used by humans and be really accessible. And that is really nice compared with other tools that at the time was designed to be used by the operating system or like other tools and not by humans. And also have support for embedded development. With that, you can compile to Cortex M, you can compile to SP32, you can compile to HTML. The support for embedded is one of the best supports that exists for embedded development by far. If you want to compile something for embedded device, you can check hardware configuration on compile time, and that is awesome because if you try to use a different register or different clock source, it can check that based on the script, like based on the software architecture, and compile the time once the hardware configuration is correct. For hardware development, this is awesome because once you have the correct hardware configuration, Rust can build and it can run. Of course, you can fight that. The biggest problem when people are starting to code in Rust is that they need to fight the compiler. Because that's what they did with like C, C++, and like trying to fight the compiler to get things running and building. But for Rust, you need to trust the compiler and follow what it says because it tries to help you as much as possible. And there is more. Rust is not a language, it's an entire ecosystem. It provides the build tools, it provides the linkers, it provides the code formatters, it provides the package management, it provides full IDE support, and much more. They also say that Rust is not like in the ecosystem, but also the community. So the community of Rust tries to embrace people and help people as much as possible. And for people that want to use ROS or any other robotic solutions, there is a big list of packages that can be used like in any or like development. As part to ROS to other other artifacts that ROS produce, has also support to DDS. So if you don't want to use ROS, but you want to use DDS to create like the publisher subscriber architecture, that is totally doable. And the list is big. If you go to the crates.rs, that's the website when Rust has the list of all libraries, you can see that it has a huge support for robotics. And besides ROS, you can also have like generic solutions. There is like the Open Rust Robotics, is a community that create solutions based on Rust. So we have like ROS integration as well in other things. There is Zeno, the Zero Overhead Network Protocol for pub/sub architecture, pathfinding, collision avoidance, URDF for people that like works with like simulations in description of robots, and much more. And there is also an example that is Rust Mavlink. It was one of the biggest examples that got based on the power of the language. With it, Mavlink, for those that don't know, is a protocol used for autopilot and other solutions that it defines the message that you're going to talk with a specific robot or a specific vehicle. It had the support for the latest spec. Rust Mavlink has support for the latest spec of the protocol. It supports embedded applications. The binaries generated by it can be lower than the default like C library provided by the Mavlink organization. And also provides async implementation if you don't want to work with threads, but like just do an in-sync code. And how that code can be used. And this is just an example of like a heartbeat message. So you just returns that's how Rust is coded. So you have like a public function heartbeat message that returns a type of autopilot mega mav message. It's just a generic Mavlink message. From that, you just construct, like you just create a script that's heartbeat data from the unknown heartbeat. In the net, we populate all the fields. Like pretty straightforward. And if you want to communicate with a vehicle, That's an example using the non-async implementation. You just wait for a message, match, you check the null type, that in this case can be an OK error or something else. If it's okay, you get the message, print the message in a debug format. That's why you have the interrogation point. And if there is a specific I/O error, so you can identify what kind of error you get, you can take the decision to wait and continue, or just print the message, what's going on. And this is just like a quick talk to talk about this, talk about Rusty, and talk how like we should embrace Rusty as a language and stop using like C++ because Rusty already provides everything, provides the library is necessary, and much more. Of course, there are like libraries that are still missing, but can be developed like quickly. And as any other language, people need to write the libraries and start collaborating with it to get popular. And that's it.
Woo! We have about 2 minutes if anyone has any questions. Patrick's open to it.
Are you going to move all the...
Can I bring a microphone to you if you have a question? We have a question.
Are you going to move the code base for RG sub to Rust?
So that I have a patch on my machine that adds support to Rust on Autopilot. The idea is to add support to Rust Madlink on the Autopilot core to add WebSocket functionality on Autopilot itself for Autopilot Linux. So I have a branch kind of work in compiling for like Autopilot in Rust, but it's still not ready to push to mainstream. But it's a work in progress in my free time.
Still time for one more question. Oh, he's got enough.
Do you think Rust is better than Python?
It depends of the trade-offs. If you need a code that needs to be like really performatic and can't break at all, Rust is the correct language. Python have some problem. Like Python is great if you want to like quick development and have something ready as soon as possible. But you also have the trade-offs of something may break, something can be incompatible, like things can go wrong later based on like how the language was designed. And that can also work like over time because of your dependencies. So it's a bit tricky. But everything depends on the trade-off. Like if you have time and you want to create a critical application, Rust is great. But if you just need to create a simple application that don't need to be performatic, Python is a good solution. The problem is like if you start putting a bunch of microservices in Python, you're going to have like a huge problem later because you have like a huge CPU usage on the startup and other things like that. But if you have multiple services in Rust, they should work just fine.
Why do I feel like you were trying to start a software war at the Innovation Theater at the end of the day on day one? Nicely done, Patrick. Not just your talk, but like evading the software war that he was trying to start. A round of applause for Patrick, please. Woo! Yeah, Patrick! All right.